So really happy to be here. I'm happy to be outside of my basement. Good. See everybody's smiling faces. My name is William Collins, and I work for a network startup called Alkira. And I didn't always work for a startup, obviously, because it's a startup. I got the opportunity to work with a few big enterprises over the years for about, I'd say 15 years, mainly financial services and healthcare. So I got a lot of, I would say, exposure and experience with cloud adoption and this thing you might have heard of called digital transformation. So it's kind of a big deal. So I'm going to talk through digital transformation and mainly what it meant for networks and network complexity. And in my experience, sort of like networking getting in the way and security getting in the way. You know, things are going pretty good. The business has made some decisions. You know, application teams they've already been building stuff for who knows how long. And then they hit network and security and it's like, oh, everything stops. So why is that? And then sort of the steps that I took to mitigate that and enable some more seamless types of migrations from data centers to AWS. At warp speed, mind you. And our definitions of warp speed may be different, but we'll get to that. So agenda is, I'm sort of gonna build a narrative around I'm basically gonna take a few different experiences and kind of mash them together, real world experiences, and just kind of build a plot. And then we're gonna jump into this, what I've always referred to as sprint, walk, crawl. And you might be thinking, hey, that's backwards. You know, you should crawl first before you can run. But this just happens to be my experience dealing in these waters with large enterprise. So we'll uncover why exactly. Then we're going to get into network complexity, like what makes it complex. It can't be that hard, can it? So we'll break it down. And then at the end, we'll kind of tie everything together and we're going to put everything on cruise control and I'll go through some examples of just sort of what we did to enable these seamless migrations. And you know, we want developers to be able to work fast. We want them to be able to work responsibly though. You know, we don't want to break network because it's a shared fault domain across like many things. So you break the network and I mean, how many of you have been in that situation where some change happened and the whole network is down? You know, DNS is down, no internet, nobody can work. You know, I was in a situation once where they had to send everybody home in a Fortune 500 company for 2 days because there was a catastrophic outage. So you want to avoid those things. So we'll go into that. So first things first, you know, we want to build a plot, and this plot is centered around the developer. Mainly because, in my experience anyway, the developers were like the movers and shakers of getting cloud going for a lot of the companies I worked for. You know, they sort of started this shift, and you know, looking back and thinking of like why was that? Like, why did developers really want to start using cloud in the first place? And you know, when I look back, a lot of that for me was seeing the experience. So developers have this platform where they can take everything. So they have their application and all the infrastructure that underpins the application, they can deploy it in the build pipeline. You know, they're not talking to change management and submitting like 5 days of paperwork to get a VM stood up that they'll see in like a month, you know? So everything's a lot quicker. It's a lot more seamless, and everything that you need is integrated into the platform. So develop experience is great, but on the other side of the developer, you know, who's using the applications and services? So you got customer experience. So when I was making this slide, I thought about like Netflix. So I have my phone and I have good cell reception or good Wi-Fi. Doesn't matter where I'm at. The network is great. My Netflix is playing. I don't have any problems. The experience is fantastic. So part of that is a really well thought through network design using, you know, cloud elasticity with AWS. So you've got the developer experience, thumbs up. You got the customer experience, thumbs up. Slam dunk, right? So what tended to happen in my experience is you'd have like these, maybe a product team or a few developers, and they went and they built either like a new greenfield application or some sort of, they used cloud to solve some problem they had just in like one instance, kind of off in the corner, kind of a, maybe even like a science project. But then you have, I'd say, the CTOs, CEOs, all the O's going to different conferences, and they talk to all their, other CTOs and CEOs, and then they start talking digital transformation. So, and the size, I want to go back and actually say the size of enterprise that I generally worked with was in between like 15 and 70,000 employees. And as far as like applications, anywhere between 100 and 2,000. So when looking at modernizing, refactoring like one application is like one thing, or a part of an application. But when you're going to look at saying, hey, we went to this conference and we come back and we want to digitally transform. We're going to migrate all these applications in a year. It's harder than that, which we'll find out. And of course, all these applications, they were born in the data center. That's where they live. And some of the companies I worked for operated data centers just in like North America, and others had data centers globally, across every continent. So just increased complexity. So back to the people up top that make all the big decisions. They went to these conferences and they decided they want to digitally transform. They come back and they remember, and this, for me, the first time I saw this happen was back in like 2014, 2014. And leadership comes back, and I remember the first time I saw, like I actually remember what I was drinking. I remember the conference room. I remember everything because it was such an interesting conversation. So I go in and we had a VP, and these big words pop up on this PowerPoint: digital transformation. I was like, what is that? Okay. So little did I know this whole thing was going to, consume my life for many years. So they decide that they want to do this, and they decide that, hey, we want to do this fast. We're just going to build a project or a program, and we're going to get it done in like 8 months. It's going to be no problem. And they have the capital that they put into it, the financial backing. Maybe they get a little bit of consultant help, and then of course, with many things, the first go around maybe isn't successful, but it's a learning exercise. So I like to, so getting to this sprint, walk, crawl, sort of scenario, I like to think of digital transformation as like learning to play music. And it might sound strange, but just bear with me for a second. And the reason I use this is it's actually a personal experience. So my wife taught music at a private school for a long time. We had kids, life changed. And then she started teaching private music lessons out of our home. Our home has kids coming in and out like all the time. So this one time, this kid comes in, his first lesson, and he like comes in, his eyes are huge, he's all happy, he's gonna learn music. He's like got pep in his step, he's sprinting in. And I'm like, oh, that's awesome and excited, young kid, wanting to play some music, great. And then I got to see him when he walked out of the house, and he looked borderline depressed. Like, I was like, what is wrong? So I talked to my wife, I asked her, like, what did you do to this poor kid? Why is he so upset? And she's like, well, he wanted to play Beethoven in his first lesson. That's what he came to learn. And I was like, oh, okay. And, I was like, how much piano experience did he have? None. This was like his first time playing. And I'm like, oh, okay, I see. So this is like digital transformation, where you go in, and this is in the earlier days anyway, but you don't know what you're getting yourself into. It's a lot more work. And it transcends just getting some consultants to come in, having a few technologies that you're changing. Like, you're transcending technology completely into the organization, the org structure, how everybody works together, all sorts of stuff. And you don't realize that in the first go around, well, at least in my experiences. So you came in sprinting, and then you kind of hit a wall. So getting to the walk phase, that student, okay, I don't have the skills to play Beethoven right now, obviously. And then with the enterprise, it's a learning exercise. There's a lot we didn't know going into this, but we realize, okay, we're going to use this as a learning exercise and allow it to inform us on how we, the next steps that we take. And then you get to the point to where, okay, the student realizes, like, in order to play Beethoven, I got to learn how to read music. Okay, there's one thing. And then with these bigger organizations, they realize, adopting cloud, and especially doing something transformative, like taking 500 applications and putting them in AWS. There's small steps you have to take first. Account mapping to like lines of business, setting up core services like security, logging, setting up network connectivity to the data center. There's all sorts of stuff you have to do, and getting security right. Working out all your IAM stuff, all your IAM policies, which is not the easiest thing in the world to do. So all these things, and on top of getting all the teams within that organization on board, that's a big thing too. Again, back to the culture. So at this point, we took off running, we're sprinting, and then we hit that wall, and then we're like, okay, there's small things we can do for wins. We're not just saying, okay, I came in and I can't play Beethoven first lesson, so I'm just not going to play music. I don't want, I just don't want to learn music. Well, that doesn't make sense. You have more information now, and you know what you have to do to be able to play Beethoven. So tying this back to the network, like what does a network even have to support? So looking at how the network is set up today for most of these big companies, like what has to change? What do they have to do, these teams, to enable these migrations and this adoption of cloud? And two things really. So the first one is you have these data centers, and you've got to be able to connect to cloud. Okay, you need a fast and reliable connection. And this always started out for me with like a VPN in the data center, using your existing internet, which seems reasonable at first, but then you start pushing a lot of data. You only have a certain amount of capacity with your internet, and you end up, I've tipping over firewalls, because firewalls can only have so much throughput at a time, session-based or whatever, depends on what firewall vendor you're using. So you can tip over physical hardware, you can cause outages, and yeah, it's just, maybe using your existing production stuff to try to figure out cloud maybe isn't the best idea, but we do need to figure out how to make that connection. And the second thing is the stuff inside the cloud. So we have some development teams, and they're really forward facing. They saw cloud sooner than anybody else. They've already been building stuff, and they're doing it the cloud native way. So we don't want to, we don't want to enforce our data center mentality and make them do things the way that we've always done it in the data center in these greenfield environments. So how do we do the networking the cloud native way and make that happen? So moving on to network complexity, and dictionary.com says it the best: characterized by a very complicated or involved arrangement of parts, units, etc. And myself, I started out working with VMware a long time ago, like physical servers to virtual server migrations, back in the day, and moving on to, getting into networking at some point, because I thought it was really interesting. because routers and the way they send around traffic, it's almost like a distributed database in a way, and it still operates within the confines of cap theorem, just like data would. So I got really interested in networking, and then this really opened up my eyes to how complex networks are built, because I think one of the main challenges is there's such a big blast radius. So developers, if they don't like something, they're like, hey, we're just going to go build a new one, and then they're going to start using it. It works better. That's awesome. With networking, we can't just say, hey, we're going to build a new network because we're going to take the business down for a month, and that will never happen, ever. So looking at some data-driven points for complexity in the network. So this Net DevOps survey, I think, is pretty interesting. It was put together by some of the folks at a company called Network Decode, which focuses on coming in to the enterprise and helping them automate like data center focused technologies. But looking at networking holistically, you have like these network engineering teams, and they'll be deploying, managing, and operating in between 5 and 24 different devices and platforms. Now, these are generally like physical, mind you. So when something breaks, you have to open up an RMA, you have to call the vendor, set everything up and set up shipping. And then when it gets there, someone's got to unbox it and replace it. It's pretty involved process. A lot different than in cloud with immutability, like, oh, we made a change. We made a change in the pipeline and we're just deploying this whole set of constructs again. A lot different than that. And there's up to 6 different solutions that are being used for generating or deploying config to all of these devices. So not only do we have a lot of different devices that maybe some have open APIs, maybe some don't. You interact with them in many different ways. A lot of different solutions used to touch them. And then those solutions that you're using to mess with the configuration and change things, they're using a whole bunch of different transport types. So, I'd say a lot of the, I don't want to say this has been normalized, but CLI and SSH, so using a tool that basically abstracts, I don't know if I'm saying this the right way, but abstracts screen scraping when you're logged into a network device. So it'll go through and like run a command, take output from that command and like do things with it, or allow you to build some stuff around it. So automating these devices isn't exactly easy. And usually the way it's done is you have small steps that you take, like, okay, I'm gonna configure this interface, add this VLAN, or set up a new port for like a new server that's gonna be connected. But getting into like routing changes and all that stuff, that is largely done by human hand, human on keyboard, going through, building some sort of configuration in a notepad file, adding it to a change order and going through change management. And it gets scrutinized really hard because what is the potential impact? Well, remember like a few months ago when you all did this static route or you removed something and you thought it was successful, but then everybody came in the morning and all this stuff was broke. You caused this much financial numbers impact to our business. So that means we're gonna scrutinize your changes even more. And this creates a stigma around changes in networking, especially around automation, that has, I think, hampered innovation in this space. And that's why network and security are definitely not the trailblazers in cloud adoption. You had compute, you had this, AWS come and, a lot of virtualization and automation. The puppets and the chefs of the world came to make, bootstrapping servers a lot easier, with your runtime automation. And these things sort of evolved. And then, through these different phases, when I think about the network, looking back, I'm thinking, okay, routers and switches doing it the same way. Maybe some little bits of innovation here and there. Firewalls, who wants to deal with firewalls? They're stateful devices that are in line with everything else. And when there's a problem with one, it just, yeah, it's a pain in the neck. So one principle that's, I think pretty important to understand, and it's really part and parcel to the whole AWS story as well, is like the problem of networking as far as underlay is concerned. So at the end of the day, you have bits going over a wire. That's happening at this layer, what is considered layer one. Then you go up to layer two, and what that is these things called switches, switching frames. And then, you get up to layer three, which is, packets and routing, which is a lot of what you see, in the cloud. The cloud abstracts that layer one and layer two. So you as a customer, you don't have to worry about it, which is awesome. So this whole underlay thing is just a kind of a hodgepodge of physical network gear and just optical infrastructure spread out everywhere. So you have the internet, which used to be, in the earlier days, it was like this meshy thing that was just everywhere. But the more the more that things have evolved, you have these things called colos, these points of presence or IBXs, and these choice locations. Like Ashburn, Virginia is a big one, and like a big portion of like all the internet traffic in the east coast of like North America goes through these hubs. So they're almost like more central, or not centralized, I'd say regionalized now. And then you have the other transports like MPLS and just traditional like layer two point-to-point circuits. So these sort of make up the underlay that you can build overlay networking on. So this is what AWS does so well. They have a lot of really thought through network infrastructure, the way that they built everything, and they have a very intelligent, logic on top of it that they can then provide to the customer to use and consume. So and this leads me into, and now this isn't necessarily true for everything, but with AWS and networking, it's definitely true. So investment, they've put a ton of capital into their network. They've built an awesome backbone, and that equals reliability and performance, of course, at a price, but it's reliable. It has reach. It's where you need to be. It's close to your customers that you're building a product for, and you don't have to worry about all the complexities that I talked about in the underlay when working with cloud services. So AWS has this significant investment in their network, and one of the things that I realized, at some point in my enterprise journey, was getting traffic onto AWS's network, onto this reliable network, is generally a good thing because they've put in that investment and they've built this awesome network. So instead of like bouncing around traffic everywhere on a whole bunch of our networks, most of our stuff is moving to cloud. We have these transformational things where we're, moving all of our applications up to cloud. And we're, at one point we were even decommissioning our data centers, not all of them, but just consolidating them. So, and that happened in tandem with our move to cloud. So I guess the next thing is, realizing that investment, realizing this network is awesome, realizing that like us as an enterprise at that point, we can't do it better. So we're, since we're moving our applications here anyway, what do we need to do next to enable these migrations and make them smooth? So the first thing, like I talked about earlier, like in those data centers that we own and manage, that's generally like how internet access happens. So, everybody, no matter where they're at, like they would actually connect to a VPN and it would come back to the data center and it would go to the internet there. And they'd have some, big beefy firewalls that they'd have to keep, buying and repurposing as capacity increased. And then you also have sites. And, a lot of the work that I did was actually in healthcare. So things like COVID, things are still business as usual when you're talking hospitals, clinics, and these types of, facilities. They have to stay up. They have to stay reliable, because there's human life on the other end of that. So you know, people coming in, connecting remotely, offices that you have to connect, all this stuff is really critical, and we don't want to do anything that's going to jeopardize that in its current state, especially on the health side. So what we ended up doing as a strategy was saying, okay, we're going to leave that alone, and we're just going to purpose as much hardware as we need. We're not going to overdo it, but we're going to maybe repurpose some of the gear we have, or bring in some new gear to connect us to direct connect locations, essentially. So, and I remember I talked about like VPNs, sort of outgrowing VPNs in the data center. And one of the things, you know, you may be asking, why not just use a VPN? You know, AWS has even site-to-site accelerated VPNs now. And the performance is really good because it's basically that same principle. You go out of your ISP and you're jumping on their network like right away. So you're not bouncing around a whole bunch of other networks before you get to your destination. Great. But when you're talking like scale of magnitude of, you know, migrating hundreds of applications, you need the high throughput, you need the low latency. There's a lot of other things you have to consider, and plus complexity. So VPNs, I wasn't going to go here, but I might as well. If you set up a site-to-site VPN connection with AWS, okay, one connection. That one connection has 2 different tunnels. So that means if you're connecting just a single VPC in the cloud to a single customer device, that's 2 tunnels. So as a best practice in that data center, you're going to want more than one physical router that these are terminating on, because what if you got to upgrade software on one of them? Well, you don't want to take down these connections. So that's 4 tunnels for a VPC. Well, what if you have, you know, 4 VPCs? You're getting upwards of like 16 tunnels. And I know Scott Willer back there, I actually worked with him on one of these transformation initiatives at one point, and he knows all the pain of what happens when VPN tunnels start bouncing and you have to troubleshoot, and it's really hard to figure out why. Even with like modern tooling, there's a lot of existential things that can cause problems that you don't think of. So like doing those and scaling those things out can be challenging. And if you have a minimal amount of VPCs, that's one thing. But if you're going into some of these big environments, you know, where we had like 40 plus VPCs, it just gets complicated very, very quickly. So back to the conversation, you know, we ended up, there's 2 ways to really do this. You can either use like point-to-point circuits and just run your BGP over, or you can just do internet, a dedicated internet access to where it's dedicated to you. And what this gives you is, you know, reliable internet that you can run an overlay over, like SD-WAN is a big thing. So if you've already have like a SD-WAN strategy in place, it makes sense to maybe do this, you know, but the point is you need to get that first connection from your data centers to those carrier neutral or direct connect location facilities. So once you have that in place, then the picture starts to get more broad. So you have the direct connect facility. You have when I first set these up, these direct connects were like physical hardware. You basically have a cross connect is what it's called. So you have your side, so you have a customer router that you own and manage inside this carrier neutral facility. And then you have AWS that has a router on the other end. And you log into the AWS portal, you order a direct connect, you do this thing called a LOA, letter of authorization, and you get these port assignments that AWS goes and provides, so the folks that own the carrier neutral facility can connect everything. So you have that base connection. But then, you know, what happens after that? So going into AWS, you know, beyond that router, what we ended up doing to enable these like seamless migrations was use something like direct connect gateways, because this is a global construct, we'll say. So it's not regional, it's actually global. So you can basically set up transit gateway in, you know, each of the regions that you reside in, and sort of like a central network account. And then that transit gateway connects back to that direct connect gateway. And then you just use VPC attachments to attach them to Transit Gateway. It works really well, and it allows you to scale your VPCs without like making a mess of everything and having a whole bunch of, call it spaghetti Italian going on. So after this sort of happened, at this point, we had some migrations going. We're doing really well. And this was like one of those things that you set up and you have the networking there, you have the capacity, and each one of these direct connects is like 10 gig. So we have 2 of those per region, and you can even use, do active there as well. But one of the things that we ran into was inside these carrier neutral facilities, we had done the enterprise thing of building out like another data center in these suckers. And that's a lot of physical hardware that you have to manage. So you're talking like 2 layer 2 switches to terminate the different, cross connects. And then, we deployed separate routers because we didn't know if we were going to want to do public VIPs as well, exchanging public tables, that can, you can't buy like a cheap router and do that. It's more resource intensive. And so we tried to scope it out the best we could. So we ended up with a lot of hardware. And then we got questions from leadership saying, hey, we're going to cloud. We're buying more hardware than like ever before. Like, do we want to stay in the data center business forever? Like, what are you doing here? And of course, this is directed towards this guy. And I'm like, well, okay. So we had everything going in AWS so well. We had that tenancy structure. We had our accounts mapped back to lines of business. We had an intake process. Things are getting automated now with Terraform. Even got network engineers coming in and like learning some of these things, which is awesome. And so what we looked at was taking, so the stuff on the left there, like this DX location and like everything before that, connecting back to our infrastructure. We ended up looking at like, the industry has a term for it, like network as a service or, network software, many different names. But what this allowed us to do was keep our AWS design intact and minimize like the amount of hardware that we have to, upgrade software on, that we have to do hardware lifecycle refresh, and this constant juggling of all this hardware. So it also allowed us to take that, like all of the network from like end to end here and actually build, like we were big Terraform users. So we built these modules and we built the control, like IP addressing, and we're gonna get to that. I don't even know how much time I have. I guess I'll keep going until somebody yells at me. But we built these golden modules and we built like this policy in those modules to where we could just publish them to a specific team, like a development team, and they can just use it. They can build networks that have connectivity end to end and has all the security built in without having to do anything else. They don't have to even reach out to us. They can just use it. And that's the ultimate thing. You need a VPC, you need a network, and you need...
In your previous slide, right, like, are you using any kind of traffic filters, like, because the cost of egress and maybe only the egress is costing dollars, but are you doing any kind of filtering, like a split tunnel VPN or?
We never did split tunnel VPN. I would say we started out doing like a single active direct connect, and then just having, the other like A side and B side, and the other B side not doing anything at all. And then we did have route filters set up. So of course we're not going to advertise a ton of. So I learned this lesson the hard way. So we had a data center, a software-defined data center project going on, and they advertised a whole bunch of host routes. These host routes got advertised up through these colos, went through the direct connect, and there's only a certain amount of routes you can send over that. And if you go over that limit, guess what? Your direct connect goes down. So we have cloud go down, and we have no idea why. For the first time in history, we actually hadn't made any changes, and it was still down. And so we're trying to figure out what to do. So yeah, there's a lot of controls that you have to have there, not only to control cost, but to control reliability. So a lot of it's filtering on the routers, and some of it is on security appliances as well. So, no problem. So yeah, going on and having these, being able to enable the developer to actually go fast, go responsibly, because I mean, if you're a developer here, do you really want to worry about IP addressing and overlapping and all that stuff between on-premises and the cloud? Do you really? I mean, I've worked in networking and I don't want to worry about that. It makes my head hurt. So, I can't imagine what it does for somebody that, that's not their responsibility. It sucks. So, and speaking of IP addressing, I'm in a lot of Twitter threads a lot where they say IP addressing doesn't matter, and all this stuff, and IP addressing doesn't matter unless you've worked in a business where you've tried to migrate something or done something. And again, this is a lesson I learned the hard way. So in the earlier days of cloud, developers had the flexibility to choose their IP ranges that they used on VPCs. And so what you ended up with was like 15 or 20 VPCs with the same CIDR range. Well, guess what? When those need to talk and you've already got all your workloads, IP addressed, well, two things with the same IP address can't talk. This is a problem. So IP address planning, it's not fun, but it's actually not hard either. From the beginning, you can set a baseline, and this is actually a combination of two different designs I did for large cloud initiatives. So, at the top, picking a large block of contiguous space, in this case, a /12 for all AWS. This is great. That's a lot of space. If managed correctly, can, get you going for a long time. And then at the region level, so saying, okay, every region that we have, AWS in, we're going to assign 2/16s. Again, that's a lot of addresses. One is going to be completely for prod. One is going to be for non-prod. And we're going to use that second octet highlighted in blue. And the odd ones are going to be non-prod, and the even ones are going to be prod. I think I got that backwards. Odd numbered are allocated to production. So, we have that. So we can basically look at an octet, and the developers know by looking at that octet what it is. Because a lot of times, you may not believe this, but they would come to us and ask us. And we just don't keep that, unless we put together a plan. We don't have that on the top of our head. We don't know. So going down to the VPC level, taking this a step further, that third octet is going to match between non-prod and prod VPCs. So 240 and 241.8, that's going to be a VPC for a product team for, prod and non-prod. And then there is a little bit of, so one of the trade-offs here, I might as well throw it out there, is you're going to have a lot more consumption in non-prod environments than you are in prod. So there's going to be, but it was never unmanageable for us from that perspective. So we never, typically exhausted space if we followed this scheme. Now, we still had instances where things would happen in the business and you would have teams run, and you can't help that sometimes. But when we followed these principles, it's really scalable. It's not hard. And the cool part is you can put this in your modules, in your Terraform, which eventually it's going to make its way into your build pipeline. So once it's automated, nobody's really touching it or having to worry about it. And that means everybody goes faster. Things are not broken. You don't have overlap. There's a lot of good pros to this. And IP addressing does matter, despite what you may hear. And I think that's it. That's all I have. Any questions?